Algebra 2 Builder number 5. This is the follow-up to the number 1 video I did. We're going to go over some Algebra 2 problems. Again, I invite the viewer to first try to work out a problem, and then afterwards play ahead to see if you got it right. And again, we have a mixture of problems here. We're trying to solve for our unknown x, and to do that, I'm first going to use the distributive property of algebra. Okay, so if we do that, distribute the 5 to both items inside parentheses and likewise on the right side of the equation. So on the left side we have 10x, and 5 times negative 3 is negative 15. And then we have minus x. And on the right side we have 3 times 3x, which is 9x. And then we have 3 times negative 4, which is negative 12. And then we can combine the x terms on the left side, so we get 10x minus x is 9x. And we have 9x minus 15 is equal to 9x minus 12. And you should be able to see something already, I hope. And if not, let's just continue. If we subtract 9x from both sides of this equation, we get negative 15 is equal to negative 12. And question, is negative 15 equal to 12? No, it is not. So I draw a little unequal sign. So there is no solution. There is no value of x that will make this statement initially a true statement. So we just write no solution. That is it. Okay, next we have solve inequalities, and here we have two inequalities. 3x is greater than negative 15 and 4x is less than 16. And a key word here is and. And then also we have set notation, set builder notation, interval notation. So there's some key words. And graphically, now usually for one variable inequality, that would indicate a number line. So let's do the one on the left first. We have 3x is greater than negative 15. If we divide both sides of the inequality by 3, we have x is greater than negative 5. Now, one thing you have to look for in inequalities, if you're dividing or multiplying by a negative number, in this case we divided by 3, so that was cool. So we have x is greater than negative 5. So we can come up here and make a number line here. And if we put negative 5 over here on the number line, and we are greater than negative 5, so greater than indicates this open circular point, and we go to the right of negative 5. So that's what the graph of this thing would look like here. And then we have our next inequality, 4x is less than 16 divided by 4. And we have was here, x is less than 4. And less than 4 looks like this. We're drawing another number line. So we have 4 here. And we draw an open circle here to represent not equal to. And we go to the left. Now, what we have to do is we say and, we combine these together. Well, to do that, we're going to put negative 5 over here and 4 over here. And we know the thing cannot equal negative 5, nor can it equal 4. But you see where the arrows are. The only place we have in common is this interval here between negative 5 and 4. And so we are just going to just color in between negative 5 and 4, but not touching negative 5 or 4. Okay, that's going to be our inequality graphical notation. Now we go to our set builder notation. And for that we have bracket X vertical line segment such that X is greater than -5 but less than 4. So that is our set builder notation. And lastly, we have our interval notation. Interval notation is going to be brackets and parentheses and commas. In this case, we have greater than -5. So by convention, we put the smallest number, which is -5, and we know that the value cannot be -5. So you use instead of bracket, use parentheses, and we go up to less than 4. So here we have the graphical notation with the number line here, and then the set builder and interval notation. Next, evaluate expressions. So we're going to take this expression here and substitute in -2 for x and 3 for y. So we're just going to rewrite this, but using parentheses every place we see an x or a y. And just every place we have an x or y, I'm just putting up parentheses here. And now what we have to do is just put in the value x and y. So that first one is 3x. We'll put in -2 every place we see x. And we place in 3 every place we see y. And what this is, it just requires you to do a correct transcription. If you do a correct transcription, you have a very good chance of getting this right. And so just simplifying, on the top we have 3 times -2, that's going to be -6. And then minus 3 times 2, so -6, and -1. And then in the denominator we have -2 minus 3 times 3 is 9. So what we have here is -6 minus 6 minus 1, that's going to be -13. And then in the denominator we have -2 minus 9, which is -11. So we are simplifying to the negative over negative cancels. We have 13/11ths as our answer here. Okay, next we have solved for v sub 2, v2, sometimes you call it. And I'm going to rewrite this v2 over t2 equals v sub 1 over t sub 1. Okay, so I rewrote this to have my unknown variable I'm solving for over on the left side. And I can do that because of the symmetric property of equality allows me to do that. So what do we have to do? What is this t sub 2 doing to this v sub 2? It's dividing. So to cancel division, if we multiply this left side by t sub 2, we can eliminate that t sub 2 in the denominator, but we have to do the same thing on the right side, the golden rule of algebra. Do it to one side, you do the other. So we have v sub 2 is equal to v sub 1 t sub 2 over t sub 1. So there we have it. Literal equation. Next. Word problems. A large candy bar costs 35 cents more than a small candy bar. And we're going to say small candy bar, we're going to call this S. Okay? And large candy bar, what are we going to call that? L for large. Now you got to be careful with S because S kind of looks like a 5, so just be aware of that. So a large candy bar, and we just sort of, now we just have to translate this from English into algebra. So a large candy bar costs, and cost would be a word that would be translated to equals 35 cents more than a small candy bar. So S plus 35 cents. In algebra language, 35 cents is 0.35 or 0.35, okay, because we're talking about dollars. And Rand wants to write an equation for the approximate cost of 5 small candy bars and 3 large candy bars. So that's going to be 5 small candy bars plus 3 large candy bars is equal to $5.50. Okay, there we go. So next, solve for the approximate cost of a large candy bar and small candy bar. Well, what we have is we can solve by elimination because we know that large is equal to S plus 35 cents. So we can take this S plus 0.35 and we can take that and plug it in for this L right here. So let's do that. We have 5S plus 3 times S plus 0.35. And we bring down what we have on the right, 550, 5.5. And then just using our distributive property, we have 5S plus 3S. And then we have 3 times 0.35. Well, 3 times 0.35 is going to be 1.05. And that's equal to 5.5. And then if we subtract the $1.05, we have, and 5S plus 3S, that's 8S. So we have 8S is equal to 5.5 minus 1.05 is going to be 445. And now if we divide by 8, we're going to find the value of a small candy bar. So I'm going to work that up here. So we'll say, you got to keep track of the decimal points in these things here. So we have 4.45. How many times does 8 go into 4? None. How many times does 8 go into 44? Well, it goes in 5 times. We put 5 here, multiply, and we get 40. Okay, or we can say 4.0. And we subtract, we get 4, and bring down the 5. How many times does 8 go into 45? Well, it's going to go into another 5 times. 5 times 8, 40. Subtract, we get 5. And this time we bring down the 0, and because there's nothing here, so if we just put another 0 here, bring down the 0. How many times does 8 go into 50? 6. Okay. So multiply, we get 48. 2 left over. Okay, well, if we divide that 20 by 8, we get 2. And if we continue this out, we get 16, 4, 0. Divide that out, we get 5. So this is what it's going to be, and it's going to be this much here, 55.6 cents. And we want the approximate cost of a small candy bar and a large one. We're gonna go by the nearest cent. So we'll say that the small, where should I write this? I'll write this down. The small is equal to 56 cents. Okay, so 0.56. We can call it $0.56, right? 56 cents. And what is the large going to be? Well, large equals 0.56 plus 35, 0.35, which equals 91 cents. We'll call it 0.91. So this is what we have. These are our answers. Again, we round it off to the nearest cent. It's kind of a not a nice round even number, but that's what we get here. I guess you could round this off to 55 cents and then let's make the large one 90 cents. That's approximate also. Okay, next. Determine if the relation is a function. Use set, builder, and interval notation for the domain range. So to find if a function, if the relation is a function, we do something we call the vertical line test. So if you create a vertical line like I did here, and you move it, you see that this vertical line touches only once. So yes, this represents a function. Okay, and we could say rationale passes. We call the VLT. I call it VLT, vertical line test. Okay, and what is the domain? Well, the domain is going to be, and we want it in what? Set builder and interval notation. So set builder is like this, x such that x such that x is greater than negative infinity. Let me leave a little more room here. I'll write like this to make sure I'll have room. X is greater than negative infinity, but less than infinity. Okay. And our in interval notation, again, as we did earlier, we have greater than negative infinity, comma, less than infinity. And for range, range is going to be the same as the domain, except for one thing. Here's the range. Instead of x, we have y. So y such that y is greater than negative infinity, but less than infinity. And our interval notation is going to be, for range, exactly the same as it was for domain. Parentheses, negative infinity, comma, infinity, close parentheses. There we have it. Let's go on to this vocabulary one. Question mark, or blank, is a set of second elements in an ordered pair or table. Well, the ordered pair is going to be, the second element is the y value, so that's going to be the range. Blank, a relation in which every input has exactly one output. Well, that's what we were looking at here. Okay, what was that? It is called a function. Next, blank, a value for variable in ordered pair that makes an equation true. Well, we tried to find that in the first problem, but we didn't find it. So the answer to that one was no solution, but what would it have been if we had a solution? It would just be a solution. Blank is a set of first elements in an ordered pair table. Well, that's going to be the domain. Okay, next. Here we have an equation, and we're asked to find different things by equations. It says find the y-intercept, form the slope, graph the function, then find the x-intercept by setting y equals 0. We can start right off here. If we find the x-intercept, we can find that simply by setting 6x and ignoring the y term. So if we say 6x equals 9, we are able to find the X-intercept. We divide by 6, simplify. X is equal to 3 over 2. So that's if y equals 0. So we can just put 3 over 2, which is 1.5, so right here. Okay, and then we can set x equal to 0 and find the y-intercept. So that would be negative 3y is equal to 9. This is called the intercept method. And so y is equal to 9 divided by negative 3. It's going to be negative 3. So we can go on the y-axis and put negative 3 down here. There we go. And what does the graph of that look like? Looks like it's slope of about 2. So I'm just going to go ahead and draw this. And we know this is a line, so we're going to continue here. I'm just going to draw some arrows to represent the continuing. Okay. X-intercept. Well, we already found what that is. So our x-intercept is the coordinate pair 3 over 2, comma 0. And the y-intercept is the coordinate pair x value 0, comma negative 3. And what is the m value? The last thing we're going to do is solve this equation for y, and then we're going to have slope-intercept form. So I put 6x minus 3y is equal to 9. And the first thing we're going to do is subtract this x term of 6x. So we have negative 3y equals 9 minus 6x. And now if we divide by negative 3, we have to divide all terms by negative 3. So we get y, I'm going to work to the right here, y is equal to 9 divided by negative 3, that's going to be negative 3, plus 6, negative 6 divided by negative 3 is plus 2x. And the last thing I'm going to do is just rewrite this in slope-intercept form by just changing the order. So it's going to be the same as 2x minus 3. So our slope is going to be 3. M equals the value of 2. Our slope is, our y-intercept is 3, our slope is 2, so m equals 2. So that's it. Okay, distributive property. I think it's the last one in our set. We have these two binomials on the left, and we can use our FOIL method to multiply a binomial by a binomial like this. I have one thing you can also do, and graphically it's more, I don't know, maybe intuitive or stable, is called this box method. I hope you've seen that before. So if we multiply 2x squared minus 5y, and on the left side here we're going to put 3x and 4y squared, and just multiply where they intersect here. So 3x times 2x squared is going to be 6x cubed. And then we have 3x times negative 5y is going to be negative 15xy. Then we have 4y squared times 2x squared. So 4 times 2 is 8. So we have 8x squared, y squared. And then we have finally 4y squared times negative 5y. So that's going to be negative 20y cubed. And you just take a glance, and we don't have any like terms at all. So we just have to write this out as 4 separate terms. So you have 6, or actually be 6x cubed minus, we have plus 8x squared, y squared. What you try to do is put the thing kind of in order of powers. Actually, powers is x squared, y squared, but that's okay. We'll put minus 15 xy, and we have minus 20 y cubed. Okay. Okay, now we have this one. We have a 2 by 3, a binomial times a trinomial. So we could, again, we could go like this, right? And then like this. I'm going to go ahead and work it out this way. And sometimes it's harder to keep track of it this way. The first thing we have is x times 2x squared. That's going to be 2x cubed. Okay. Next we have x times negative 4x, which could be negative 4x squared. Next we have x times 5, which is going to be plus 5x. And now we go ahead with the negative 3. Negative 3 times 2x squared is going to be negative 6x squared. Negative 3 times negative 4x is going to be plus 12x. And finally, negative 3 times 5 is going to be negative 15. And then you look where you have like terms. The like terms we have are the squares and also the x's. So let's go ahead and, but 2x cubed just stays the same. Okay, we have negative 4x squared minus 6x squared is going to be minus 10x squared. And then we have 5x plus 12x, that's going to be plus 17x. And finally we have negative or minus 15. And so this would be our correct answer for that. I hope this has been helpful to you, and you got some right, you've learned where you have room for improvement. Good luck, and thanks for viewing.